Welcome to the webcast for the Transporter 12 mission. Falcon 9 is currently scheduled to lift off in just under 11 minutes and 14 seconds from now from Space Launch Complex 4 East at Vandenberg Space Force Base, which is just a few hours north from us here in Hawthorne, California. Hey everyone, thanks for tuning in. I'm Somi Srivastava, a heat shield engineer here at SpaceX, and I'll be your host for today's mission. We are thrilled to be sending an incredible 131 payloads on today's flight, including CubeSats, microsats, and orbital transfer vehicles carrying 30 of those payloads, 14 of which will be deployed at a later time. All spacecraft will separate from the second stage across 101 deployment events, scheduled to start around the T plus 54-minute mark and conclude about 2.5 hours after liftoff. This launch marks our 7th flight of the year and our 14th dedicated smallsat rideshare program launch between our Transporter and Bandwagon missions. To date, SpaceX has launched more than 1,100 payloads to orbit for more than 130 customers across our entire rideshare program. If you're interested, a full list of payloads are on spacex.com/launches. We are currently working towards a liftoff of 11:09 a.m. Pacific time, which is in about 10 minutes from now. If needed, there is a backup launch opportunity tomorrow, January 15th, at the same time. But right now, the weather is currently green on the Central Coast, and the range is ready to support. With that, let's take a look at one of the payloads launching on today's mission, MBZ-SAT. Developed entirely by UAE engineers at the Mohammed bin Rashid Space Center, or MBRSC, the MBZ-SAT Earth Observation Satellite will become the most advanced satellite in the region, offering unprecedented image accuracy and offer improved data transfer and download speeds. Here's more from our customer, MBRSC.
It's our biggest satellite that we've ever built. It's about 1-ton system, producing very high quality resolution data that will benefit a lot of entities locally and globally. But the key factor here is that this satellite is fully designed, integrated, assembled, all of the software, everything is done here at the Mohammed bin Rashid Space Center.
You can imagine from 500 kilometers you can image a square. That gives you the ability to put these pixels back with each other to create an image. And that image will give you the ability to extract information.
It's very exciting to work with a team that is full of experts who have gained knowledge from different projects all over space. So it's really exciting to work with the team.
The Falcon 9 rocket supporting today's mission is a 2-stage rocket designed for reliable and safe transport of satellites, cargo, and people. At the very top of the rocket is the payload fairing. The fairing is a protective shell that houses all the payloads, shielding them from the aerodynamic heating until the vehicle is outside of the Earth's atmosphere. The aerodynamic shape of the fairing also contributes to Falcon 9's overall efficiency, helping to reduce drag while the vehicle accelerates through the atmosphere. Once in space, the two fairing halves separate and fall back to Earth, where they will be recovered by one of our recovery vessels to be refurbished and reused on future flights. Both halves of this fairing are flight-proven, with one side flying for its 19th time today and the other for its 18th time. And inside those fairings is today's payload stack, which was encapsulated just a few days ago, and this is actually our tallest stack to date.
Engine chill has started.
Right below the fairing, we have our second stage, which houses our single Merlin vacuum engine, or MVAC, which will take our payloads to their drop-off point. Below the second stage is the black carbon fiber inner stage, where the MVAC engine is located. The inner stage connects the two stages and houses a center pusher that allows the first and second stage to separate during flight. Below that, we have the first stage, which we usually refer to as the booster. The first stage makes up the bottom 2/3 of the vehicle and has 9 Merlin M1D engines at the bottom. Those 9 Merlin engines generate more than 1.7 million pounds of thrust.
Stage 1, RP-1 load is complete.
The first stage supporting today's mission will be marking its second flight today, having previously flown the NROL 126 mission. At about 2.5 minutes into flight, the first stage will separate and make its way back to Earth and attempt a land landing at LZ-4, which you see right there on your screen, which isn't too far from the launch pad. If successful, this will be the 397th landing of an orbital class rocket. Because this is a return to launch site landing, during re-entry, when the booster slows down from supersonic speeds, people in the immediate area may hear a brief double clap of a thunder-like sound referred to as a sonic boom. Reusability is the key to our future in space, and the sonic booms created by returning boosters are unique to reusable vehicles. Similar sonic booms were heard during the return and landing of NASA's space shuttle and famously occur following a Falcon Heavy launch when 2 side boosters return at the same time to the launch site at Cape Canaveral, creating a unique double sonic boom. While these have become well known to rocket enthusiasts at the Cape, they're becoming more well known on the Central Coast and Texas, where our Starship vehicle's Super Heavy booster returns to the launch tower. To get an idea of how this looks and sounds, here's a look at what some of these booster returns have looked and sounded like on a few previous missions.
I know a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show because you're going to hear those sonic booms.
Booster landing leg deployed.
Sonic boom is great for us.
That thunderclap broke the sound barrier.
Side booster separation confirmed.
Just heard the 2 sonic booms here in the room.
Booster landing confirmed.
At just under T-minus 4 minutes, all systems are currently go for an on-time liftoff. Next up, the truss structure next to the vehicle, known as a strong back, will start to retract. In preparation for retraction, the clamps around the second stage will open, which, if we look on our screen, they have already opened, and then the strong back will recline away from the vehicle, which you can see it is slowly moving away. In addition to helping drive down the cost of access to space by flying reusable vehicles, SpaceX's dedicated rideshare flights to sun-synchronous orbit provide small satellite operators competitive pricing, increased flight opportunities, and flexibility. As the demand for rideshare missions continues to rise, our rideshare program was expanded to accommodate even more small sats looking for rides to orbit. Falcon 9 launched its second bandwagon mission last year, Bandwagon 2, a separate line of rideshare missions to deliver spacecraft to mid-inclination orbit rather than to transporters to sun-synchronous orbit. Mid-inclined orbits are appealing to a growing number of customers, especially to remote sensing companies that want to strengthen their coverage over areas like parts of Asia and the Middle East. Rideshare significantly increases access to space for small satellite operators around the world, and we're excited to be able to offer these launch opportunities for our customers. For more information on these and opportunities to other orbits, visit spacex.com/launches. So at T-minus 3 minutes, we had LOX load completion on the first stage, and we're coming up on LOX load completion on the second stage in just under 15 seconds from now.
Stage 2 LOX load is complete.
Great call out there, telling us that Falcon 9 is now fully loaded with propellant. Coming up around at T-minus 1 minute, Falcon 9 will be in startup, which is when the internal flight computers will have taken over.
Ground gas closeouts.
That white cloud is venting from the TE LOX line, which is completely normal.
Falcon 9 is in startup.
Launch director, go for launch.
We just heard from the launch director, so at T-minus 40 seconds, all systems are go for launch of Transporter 12.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff of the Falcon 9. Go SpaceX. Go Transporter 12.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
We are now 32 seconds into flight. Falcon 9 has cleared the tower at Space Launch Complex 4 East, and we're currently throttling down to prepare for max Q, which is the point of maximum aerodynamic stress on the vehicle.
Power and telemetry nominal.
Falcon 9 is supersonic. Max Q.
We just had max Q. Now we have 5 events coming up in quick succession, starting with MECO, then stage separation, stage 1 flip, second engine start or SES1, and the start of boost back burn.
MVAC chill has started.
MECO is main engine cutoff when all 9 M1Ds on the first stage shut down. Stage separation is when the first and second stage separate from one another. Stage 1 flip is when the booster flips 180 degrees. Second engine start is when the MVAC engine on the second stage will light for its first time. And boost back burn is used to arrest the forward velocity and return the first stage back towards the landing site. So all of those coming up in a few seconds. Watch out for them.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
And there you heard, and we had some awesome views of those 5 events that happened back to back, which are main engine cutoff, stage separation, stage 1 flip, second engine start 1, and boost back burn on the first stage. Coming up next will be fairing separation.
Fairing separation confirmed.
Great call out there of fairing separation and an awesome view of our payloads. As a reminder, those fairings will make their way back to Earth for recovery. Both halves of the fairing are flight proven, with one side flying for its 19th time and the other for its 18th time.
Stage 1 boost back shut down.
And we just had the end of boost back burn. The next major milestone coming up is entry burn on our first stage, which is scheduled to occur around the T+6 minute mark.
Vehicles are on a nominal trajectory.
On the left-hand side of your screen, we just saw the 4 grid fins deploy. Falcon 9 is equipped with 4 hypersonic grid fins positioned near the top of the first stage that help steer the first stage as it returns to Earth. And we're currently in our first MVAC burn, and this burn should last for another few minutes. And as I mentioned, the next milestone will be the first stage entry burn, which is coming up in about a minute and a half. Today, Falcon 9 is performing 2 burns in order to land. That first burn, known as the entry burn, slows the vehicle down before hitting the denser parts of the Earth's atmosphere. Today's entry burn will be a single-engine entry burn where only E9 will relight. Without this burn, we'd only be using the atmospheric drag to slow down Falcon 9, which would add extra stress to the vehicle. Following entry burn, the booster will initiate the landing burn, which should slow down the vehicle even more for a successful landing. The white puffs coming off of Falcon 9 that you see on your screen are cold nitrogen gas, which help with attitude control. An awesome view of the Channel Islands on the right-hand side of your screen, coming up on the start of entry burn in just a few seconds.
Stage 1 entry burn startup.
There's the start of entry burn. It should last about 15 seconds.
Stage 1 entry burn shutdown.
And we just had confirmation of entry burn shutdown. And as I mentioned earlier, we will be attempting to recover this booster for the second time today and are targeting a landing
Stage 1 FTS has safed
at Vandenberg's LZ-4. Today's landing burn attempt will be a 3-engine landing burn where engines 1, 5, and 9 will relight to really quickly slow down the vehicle before touching down.
Stage 1 transonic. Stage 1 landing burn.
Start of landing burn.
Stage 1 landing leg deployed. Stage 1 landing confirmed.
And as you saw and heard, we had successful first stage landing at landing zone
Stage 2 internal
4.
guidance.
Which marks the second landing for this specific booster, which previously supported NROL 126. This marks the 397th landing of an orbital class booster. Next up, we're expecting the shutdown of the second stage MVAC in about 10 seconds from now.
Stage 2 FTS has safed.
Nominal parking orbit.
We just had successful cutoff of our second stage engine, and we heard the call out for good orbit. Coming up next, we have the second burn of our MVAC engine on board the second stage, or SES-2, around the T plus 50 minute mark. After that, the first batch of deployments will begin at about T plus 54 minutes. We'll be back in about 40 minutes to bring you live coverage of SES-2. Until then, enjoy the space views, and we'll see you back here soon.